Okay, so let's get started. This is the Cosmos SDK Community Dev Call. This is a monthly call to talk about features and development in the Cosmos SDK. This call is looking back on the month of August. The agenda today is to go over these items here, the 4.2.9 release, 4.3.0 release, the official 4.3.0 release, and Cosmovisor V01, look at what's next and talk a little bit about working groups, and then I'll do an OSCE module. I'm going to kind of run through those early items pretty quickly because we've discussed the 4.3 release pretty in detail, but and we've talked about what's next a little bit in the previous meeting. So I want to do a little OSCE module demo. So go through these pretty quickly. But first off, the 4.2.9 release went out on August 6th, and this had 3 changes that were added. One was fixing an issue introduced in 4.2.7 where IBC was unable to, it was prohibiting IBC to create new channels. So we fixed that in the capability module. It was having to do with the initialize and seal method. And it requires to update an app module managed by adding X capability module to begin blockers. The next up fixed app init recovery mode, where the mnemonic was not handled correctly. And then also we changed the app transaction distribution withdrawal rewards CLI by focusing the broadcast mode if a chunk size is greater than 0. This is going to ensure that the transactions do not fail even if the user uses invalid broadcast modes for this command, such as sync or async. But yeah, the 4.3.0 release, we've talked about this quite a bit in detail on previous calls, so I'm not going to go over it here again, but the official release is out. It went out on August 10th, so we're happy to have that out. It was a significant release with a lot of breaking changes. The scale of Stargate release, and moving forward, we're going to be trying to focus on doing a little bit smaller chunks and releases, and we'll take a look at that here in a second. But these are the main features that were included in the 4.3 release. And as I mentioned, yeah, previously we've talked about these a little bit more in detail, so you can go check out those previous community dev call updates if you're looking for more information about this, or we can discuss it too in the open discussion. So Cosmovisor V01 went out August 6th, and this was the first release of Cosmovisor. Previously, validators and node operators have been using Cosmovisor by building it from the Cosmos SDK repository. Cosmovisor is currently in the Cosmos SDK repository. There is some requests and discussions about moving it out, but this is the best way currently to test out independent modules within the repository, and also to make sure that Cosmovisor is getting noticed by the community and it's easy to find in terms of discovery. So V01 went out, and this is monitoring STD out for upgrade proposals. The change that's going to be made to determine the V10 upgrade is we're going to be switching to File Watcher instead of monitoring STD out. And this is like a more reliable and secure way of monitoring for upgrades. But both of these versions have this backup option enabled by default now. So the reason Cosmovisor V01 to V1.0 upgrading to the File Watcher is because there's some edge cases with V01. So we wanted to ensure that there was a backup option enabled there where chains would run into a race condition. So yeah, V01 is available. And just a quick note here too, that Cosmovisor V01 supports all Cosmos SDK versions, but there are those edge cases, whereas V1.0 only supports Cosmos SDK 43 and beyond. But if you're wanting to use the auto download option. So if you don't need the auto download option enabled, you can use it with all Cosmos SDK versions. But if you want it to use the auto download option, Cosmovisor v10 will not work with Cosmos SDK 42. So what's next? The last community call, we went into a little bit more detail on these 3 items. So I'm not going to do that again here, but these are our high priority items, and we're shooting for a 4.4 release end of October. Optimistic about that. And this was focused on providing support for the Gravity Bridge. And then following that, these are a number of features in development within working groups that are for the 4.5 release and beyond. And if anyone's interested in taking a look at some of these different features that we're implementing and getting involved with the engineering teams in the community, we have these working groups, and this is a pinned issue in the Cosmos SDK. So if you're interested, you can hop in there, and there's links to the discussion and the epic and the related issues, and you can get familiar with it really easily by just checking out that pinned issue in the SDK. And we also have architecture review calls and working group calls. So there's a lot of opportunities for community members to get involved. And as I mentioned, we're going to do a quick demo on the authorization module. I'm going to go ahead and just use the SIMD, or I'm using SIMD, which is the binary for the SIM app application that's included in Cosmos SDK for demonstration and testing purposes. I'm using the 4.3 branch. So the authorization module is introduced in the 4.3 release. So I've already built the binary, and here I'm just showing that that's the version that I'm using. I'm going to do a couple configuration settings to get the chain started, but I will slow down once we get to the actual authorization. So I'm going to add a key here. I've got a tutorial that's in development, so I'm going to use actually a mnemonic that is consistent so that the addresses in the example are consistent as well. All I'm doing here is creating a couple keys. We're going to have Alice basically grant an authorization to Bob to vote on behalf of Alice. And so, yeah, we've added a couple keys. We've configured the binary. Now I'm just going to do a couple commands to start the chain, initializing the chain, adding Alice to the Genesis account, adding Bob to the Genesis account or Genesis file with an initial balance. And then we're going to generate that validator transaction for Alice. So she's going to be our validator. We're going to collect it and add it to the Genesis file. And then we can start the chain. So that's all the preliminary work unrelated to the authorization module, but just things to get this up and running to show you an example with the authorization module. So we are going to grant an authorization from Alice to Bob to vote on her behalf. So the first step is actually to just create a government proposal so that we can test this out. Here we're doing SIMD transaction gov submit proposal. The title of this proposal is test authorization, and the description here is Bob authorized to vote? This is just a text proposal. We're putting down the initial deposit, and this is coming from Alice. So we've confirmed that transaction. We can just go ahead and query it just to see that it's on chain and it was successful. And then now we're going to run the authorization grant method. But before I do that, actually, let's just take a quick look at the auth available commands. So with the authorization module and with the CLI here, we've got an exec option for executing a transaction on behalf of the grantor. We've got a grant option, and we've got a revoke option. So we're going to start off by granting an authorization from Alice to Bob to vote on her behalf. And that looks like this. So here, I don't know if you can see my screen. I'll pop that in there at the top. So we've got, that's this query. Whoops. So here below this query, we've got the transaction auth_z grant, and this first address is Bob. So we're granting Bob a generic authorization. There's different types of authorizations. There's a send authorization where you can provide a spend limit. And there's a generic one. There's also delegate, undelegate, and bond relating to the staking one. We're just using the generic authorization, which allows you to provide a message type. And that message type is the message vote message type. So, and this is coming from Alice. So the generic one will just allow Bob to vote as many times as he wants on behalf of Alice. So we'll run that here. And then we'll run the query method that I posted above just to double check that that's on chain. And so we see that it is, the authorization exists. And now we will create an unsigned transaction. So this can be done from Bob's computer. He doesn't need to have Alice's key because he's only generating a transaction here. But essentially what we're going to do is run the vote command for proposal 1, which is the only proposal on chain at the moment, saying yes, and this is coming from Alice. So we provide from Alice, even though this could be run on Bob's computer, and we're going to run the generate only option and put that into a tx.json file. So we'll run that, and then we can take a look at the JSON file here, and you'll notice that there are no signers on the transaction, and the transaction voter for the voting on this proposal is the address for Alice. And so now, once again, imagining that we're on Bob's computer and he has created this transaction JSON file in order to submit a vote on behalf of Alice, then he can run this command, which is the auth_z exec command that we saw earlier with the help method. So running that from Bob's account, we can go ahead and confirm that transaction. And then we will see the vote by running a query for the vote on proposal 1 with using Alice's address. And we can see that Alice has voted yes on the proposal. So that's a quick little overview of the authorization module. And we're about 15 minutes. So we'll go ahead and move into open discussion. But yeah, I'm going to go ahead and stop the recording now, and we'll open it up to the floor for questions and comments and anything that anyone wants to discuss. So thank you.